Hello, my fellow scientists. Welcome to our study today, whereby we are in part 5 of finding the inverse of trigonometric function. Today, we want to get the derivative of cot inverse of x. Here, what we are going to do, we are going to multiply both signs by, we will multiply this equation by cot, both the left-hand side and the right-hand side, to get cot y is equal to cot times cot inverse x. Using the laws of indices, we find that cot times cot inverse, this is the same as cot power 1. Cot power 1 times cot power -1 is, using the laws of indices, we are going to add the index because we are multiplying. So 1 plus -1 is cot power 0, which is equal to 1. Any number power 0 is equal to 1. Then here we are going to be left with 1. We will be left with 1. 1 times x is equal to x. So cot y is equal to x. Differentiating both signs implicitly. This is an implicit function. So cot differentiated will give you negative cosec squared, negative cosec y squared, dy over dx, because it is an implicit function. X differentiated with respect to dx is 1. We divide both signs here by negative cosec y squared to get negative 1 over cosec y squared. Now we can use a right angled triangle whereby we know we are given cot y. So cot y is given by adjacent over opposite, adjacent over opposite. So that one guides you to know how to draw your triangle. So that is why I've drawn this triangle here as adjacent is x, opposite is 1. So cot y will be given by adjacent over opposite, which is x over 1. Then using Pythagoras theorem, we can get hypotenuse, which is x squared plus 1 squared, then you get square root. Now from there now, we come here and substitute our answer here. So dy over dx will be equal to 1 over cosec 1 over cosec squared y. Now again, from the trigonometric ratio, cosec is given by cosec y is given by hypotenuse over opposite over hypotenuse. So our hypotenuse, cosec y is given by hypotenuse over opposite. So hypotenuse is square root of x plus 1, square root of x plus 1, which hypotenuse is square root of x plus 1, which is recorded here, divided by 1. Yeah, cosec y will be given by hypotenuse over opposite, which is square root of x plus 1 divided by 1. Now substituting the value of cosec here, cosec squared, so the square root will disappear and we will be left with the 1 over cosec squared, which is x squared plus 1. Alternatively, you can use trigonometric ratio. Sine of y squared plus cos y squared is equal to 1. Dividing both signs by cos squared y, we are going to get here is dividing both signs by sine squared y. Here we will be left with 1 plus cos squared y over sin squared y is equal to cot y squared, which is equal to cos x squared of y. Now, we know from above here that cot y is equal to x. Cot y is equal to x. So 1 plus cot y, which is now cot squared x squared, is equal to cosec squared y. So substituting in this formula, dy over dx is equal to negative 1 over cosec squared y, which is equal to negative 1 over x squared y. And that is the end of derivative. So that is how we get the derivative of trigonometric inverse, whereby we follow this simple step and we are able to get our answer as indicated here. Our next consideration will be finding the derivative. We will be finding the derivative of y prime, given that y is equal to cosec inverse of x. So be tuned even as you are going to do that. So this is a simple step whereby first of all you multiply this equation both sides by cot, and you are going to get this. Then you apply the laws of indices. Here it is cot power 1. It is multiplication, so you add the powers. Any number power 0 is equal to 1. Then you have cot y, which is equal to x, because this is 1 times x, which is equal to 1. Then you differentiate this function. It is an implicit function. Once you differentiate both signs with respect to x, here we are going to get negative cosec squared y, which is dy dx, which is equal to 1. X differentiated with respect to, we will get 1. Then you divide both signs by negative cosec y to be left with dy dx. Then using this right angle triangle, we know cot y is given by opposite, adjacent over opposite. Adjacent is x, opposite is 1. By Pythagoras theorem, the hypotenuse will be given by x squared plus 1 squared, which is you get the square root. Then cosec y is given by hypotenuse over opposite. Hypotenuse over opposite. Our hypotenuse is square root of x squared plus 1 divided by 1. Then we come here and substitute. Instead of now cosec squared y, you write x squared plus 1. Alternatively, you can use this trigonometric ratio. You can use this simple trigonometric ratio given here. Sin squared y plus cos squared y is equal to 1. 1 plus cot of y squared, which is equal to cosec 1 squared plus y. This cot, what you have done here, I have divided here by sin y squared. Cos y squared divided by sin y squared is equal to cot squared y. And here 1 over sin squared is cosec squared. Then from above here, we found that cot y is equal to x. So you substitute cot with x and you square. So 1 plus x squared, which is equal to cosec y squared. Then derivative dy dx is equal to negative of 1 over cosec squared y, which is equal to negative 1 over x squared plus 1. So next time we are going to be looking at finding the derivative of that, given that y is equal to cosec inverse of x. So stay tuned as we keep on learning. For the previous learning of number 1, 2, 3 up to 4, you can check in my channel and you are going to learn in step-by-step learning.